Evaluate integral of x squared times quantity x cubed plus 2 to the power of 4. Okay, so we want to integrate. Sounds very Borgish. Time to integrate. Do they use the, I wonder, that is not a good use of my time figuring out how often integrate is used in reference to the Borg in Star Trek. I imagine it's fairly often. Okay, focus. So for this one, we're going to do substitution. Use substitution. So I'm going to say u squared equals x cubed plus 2. The reason I think this is you see that one of these things is the derivative of another. So specifically, when we look at x cubed plus 2, when we take the derivative of that, we get x squared, which is kind of a giveaway that, okay, we're going to use u substitution. So we say that u equals x cubed plus 2, and du will equal 3x squared dx. Now a lot of people kind of stop from here. I like to take this one step further and write du over 3 equals x squared dx. That way it is abundantly, more contrast, there we go, clear that you have x squared here, x squared there, dx here, dx there, 3x, there's no dx, no, there is dx, what? X cubed plus 2, x cubed plus 2. And so everything is directly substituted in, and it makes it easier for me in my old age. Ooh, cyan. So we have integral of du over 3 times u to the 4th. So I wrote that kind of backwards, so I'll rewrite it. So we'll have u to the 4th. I'll say 1/3 u to the 4th du. And I just moved the moved the 1/3 outside the integral because it's a constant and we can, and it's easier. Okay, so now we know how to do the power rule here. So it'll be, I can do a better u over 5, and then it'll be plus c. Yes. So there's no limits of integration here, so we don't have to worry about converting the limits of integration, which I usually try to avoid anyway. So this will be 1 over 15 u to the 5th, which equals 1 over 15 times x cubed plus 2 plus c. Let's see if they want. Yep, we can probably, to the 5th. Good call. Thank you. Almost missed that. Go team. Go team. And so our answer here is going to be over 15. Check. X cubed. Check. 2. Check. 5. Check. And then it's c for a constant. Okay. Just in case you had trouble seeing. I assure you didn't. But I will show you anyway. There we go. That's the answer. Is it? Yes. Totally an answer. So back, big picture, we see this. Our first thought is, want to do power rule because that's probably the easiest. We're like, nope, power rule doesn't really work because we have, does it? We could use the power rule here. So, not to get too far tangent, but we could take this x cubed plus 2 to the 4th, and we'd probably end up using like a Pascal's triangle type thing. 1, 4, 6, 4, 1. That's supposed to be a 4, not a 9. That's n equals 1, 2, 3, 4? No. There we go. 0, 1, 2, 3, 4. And so we have, we could calculate that out, expand it, and then multiply everything by x squared and get an answer, but it would be a huge pain, and we don't want to. It is better to recognize that we have a x cubed plus 2 here, which when we take the derivative of that, we get x squared. So you immediately want to cue on things where, okay, that's a derivative of that. That kind of clicks in your head. It's like, all right, we're going to follow the path of u substitution. You say what u equals, which is the pre-derivative, the x cubed plus 2. Take the derivative, substitute it in, change everything back, and there's your answer. In this case, it's this guy right here. Thank you. That's how you solve the problem, and see you on the next one.